Okay, everybody, I was going to create a little bonus video today to help us with something that I think we're struggling with, and that's reflections. So to do reflections, I'm going to start with section 6.8 here, question number 4. It's one of the more complicated reflection questions that we have. I want to start there to kind of give us the full spectrum of what's going on here. 4 asks us to reflect quadrilateral A, B, C, D over the line y equals 2 plus x, and label the image A prime, B prime, C prime, and D prime. So this is our pre-image right here. This is our pre-image. And so the first thing we have to do is we have to find the line of reflection. Now y equals 2 plus x isn't in the form that we're used to. We're used to y equals mx plus b, but we can easily see that y equals 2 plus x can easily be reconfigured to say x plus 2. And so that tells me that my intercept is at 2, and my slope is 1. So that means I go up 1 over 1, up 1 over 1. So I'm just going to do these dots to make sure that I get my line precise, because I do like a precise line. Go ahead and take my ruler, and draw it, and there we go. So that's going to be the line around which we reflect. So that means when we're reflecting across this line, it is like the line itself is the mirror. And so we have to go directly towards the line. And to go directly towards that line, we have to look at what is perpendicular to that line. So when I do that, I have to look at my line slope. So the slope of my line, in this case, there's no number there, but we all know that really means that the slope is 1. And so that means that the perpendicular slope to this line is going to be the opposite inverse. So in which case, this is 1 over 1. If I flip that, it's still 1 over 1, but it has to be opposite, so it's negative 1. So what I'm going to do is from each point is I'm going to travel at a slope of negative 1. So from A, I'm going to work towards my line of reflection at a slope of negative 1. So that means I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and I get there. And I see that I've gone 1, 2, 3, 4 slope lengths. So that means my reflected image is going to be 1, 2, 3, 4 slope lengths away. So 1, 2, 3, 4. And so this will be my A prime. Okay? And I can see that this length is just as far away as that length. And I can prove it if I really need to. You know, I can create a little triangle here. You know, I can do a little triangle from A to A. I see that this is 4, this is 4, and then I can do the same thing. This is 4, this is 4. So these lengths in between them must be the same thing. It's 4 squared plus 4 squared equals my C squared. Or 16 is 32 equals C squared. So this length here is the root of 32. And that's going to be true for both of them. It's the same distance, so they're just as far away from the line. Thus, they are reflected. But I'm going to do that again with all my other points. Down 1 over 1, down 1 over 1, down 1 over 1. And I see it's halfway through, so I got to keep that in mind. I only got to go halfway to get there. And then down 1 over 1, down 1 over 1, down 1 over 1. And so this is going to be my B prime. Okay. And I can even see here that there's a small triangle that I make. I go up 1 over 2, over 1, up 2. Same thing. So I'm going to do the C. That's 2 lengths. That's my C prime. I'm going to do the D. 1, 2 and a half, 1, 2. So that'll be my D prime. And so now I have my reflected image right there. And so that's how I reflect across a line. Now we're going to do something else. Now that I've done this, I'm going to do the second part of this question. The second part of this question asks me to do something, a different kind of transformation. In this case, it's asking me to rotate. It wants me to rotate my A prime, B prime, C prime, D prime, so my image, my new image, counterclockwise, going this way, counterclockwise 90 degrees around the point -2, -3. Okay? So first I have to find the point -2, -3. So I have to go over 1, I have to go back 1, 2, and then I have to go down 3. 1, 2, 3. All right. So now I'm going to go counterclockwise around this point. And so to do this, I have to look at each point individually and see how far away it is from my rotation point. So I'm going to start with A. I'm going to go in alphabetical order. And to get from my point to A, I'm going to figure out what the slope is. And the slope tells me I go up 1 and over 1, 2, 3, 4, 5, 6. Up 1 over 6. Okay? So if this is 1/6, what I'm going to do is I'm going to rotate this. I can view it kind of as a line, kind of as a triangle. And so I'm going to rotate it counterclockwise. So this one that's going up is now shifting 90 degrees counterclockwise. So now that 1 is going to be going this way. So I get rotated along that. And then I have to go up 6. 1, 2, 3, 4, 5, 6. So that our old image of C is now our new image of A prime prime. I'm going to do the same thing for B. For B, I see that I have to go up 3, so that means I have to go over 3. And I see that I go over 1, 2, 3, 4, 5, 6, 7. So that means I have to go up 1, 2, 3, 4, 5, 6, 7. So that this becomes B double prime. And then I got to see my C. My C I go up 2, over 3, 1, 2, 3. So that becomes my C triple prime. And then I see that D is just 2 over, so that means D is just going to be 2 up. And sure enough, I now have my new image. There we go. I get nice and neat there. Yeah, that's what I get. That's what I get by rotating it. So using those methods for reflection and rotation, you can apply those to many different things, many of the different problems I'm going to ask you to do. Sometimes there'll be just one point you have to reflect, sometimes not. But this whole process of being able to find that perpendicular is incredibly important. And then the rotation, counting, and viewing it as small triangles that you rotate is also incredibly important.